Hi, I'm Shervin, and today I'm going to be talking about hazardous mixtures of certain acids and bases, and how the proper dilution or neutralization of such dangerous solutions can prevent accidents. Let's start out with the basics. What exactly are acids and bases? According to our textbook on Chapter 10, Section 10.1, Arrhenius' theory of acids and bases suggests that an acid is a substance that dissociates in water to produce one or more hydrogen ions. A base is a substance that dissociates in water to form one or more hydroxide ions. This theory tells us that acids increase the concentration of hydrogen ions in aqueous solutions. This is why an Arrhenius acid must have hydrogen as a source of hydrogen ions. However, bases increase the concentration of hydroxide ions in aqueous solutions. Thus, the base must contain the hydroxyl group as the source of hydroxide ions. Now there's another scientist who has come up with another theory of acids and bases. His name is Bronsted-Lowry. Bronsted-Lowry's theory of acids and bases is an acid is a substance from which a proton is a hydrogen ion that can be removed. A base is a substance that can remove a proton from an acid. But then we have strong and weak acid and bases. You can refer to section 10.2 for more information, but since I'm short of time, I'm going to have to shorten it a little bit. So an acid that dissociates completely into ions in water is called a strong acid. Here's an example. In this reaction, the acid, hydrochloric acid, completely dissociates into hydrogen ions and chloride ions. On the other hand, an acid that dissociates in very small amounts in a water solution is called a weak acid. An example of this is shown in the following photo. In this reaction, only about 1% of the acetic acid molecules dissociate. Now I'm going to give a brief description of strong and weak bases. Just like strong acids, the strong bases completely dissociate into ions in water. A base, just like weak acids, dissociates very slightly in a water solution. Most bases are weak, and a common example of a weak base is aqueous ammonia. Aqueous ammonia, only 1% of its molecules react with water to form hydroxide ions in a 0.1 mole per liters of solution. Now I'm going to talk about neutralization. According to Chapter 4, Section 4.3, neutralization reaction is a special type of double displacement reaction that produces water. Neutralization involves the reaction of an acid with a base to form water and an ionic compound. So how do you neutralize a solution? As you might know, in order to prevent hazardous solutions to harm us, we need to neutralize them. This can simply be done by adding a base. While the acid has a pH of less than 7, you can see here, and a base has a higher pH. As demonstrated in the lab quite a while ago, a strong acid such as hydrochloric acid can be neutralized by a strong base like sodium hydroxide, while weak acids are neutralized by weak bases such as baking soda. The result is usually water and salt. Let's cover hydrochloric acid and sodium hydrox case. In this case, the result would be sodium chloride and H2O, salt and water, as they say. But now I have even a better way to explain how neutralization works. This will be demonstrated by a video I've provided. Shown here, hydrochloric acid contains hydrogen ions and chloride ions in aqueous solution. Next, we have sodium hydroxide, which contains sodium ions and hydroxide ions in aqueous solution. When we combine these two solutions, a neutralization reaction occurs. In this reaction, hydrogen ions from the acid and hydroxide ions from the base combine to form water molecules. The sodium and chloride ions are not affected. They remain to form a neutral sodium chloride solution. Neutralization can generally be summed up by this simple ionic equation. Hydrogen plus hydroxide reacts to form water. One might wonder what kind of benefits acids and bases provide us with. This was quite extensively explained in Chapter 10 on page 369, but I'm going to briefly talk about the benefits and some of the risks taken later on. We should all know that acids and bases are very useful chemicals, because even though some people think only recently they've become useful, they've actually been, in fact, used for thousands of years. Vinegar is one example of one of these very useful solutions. Vinegar is an acidic solution which is common in many food and cleaning products. Today, acids are used to produce fertilizers, plastics, motor vehicles, and in the past decade or so, even computer circuit boards and many more advanced products. Bases are also quite useful in our lives. Starting from as early as 5,000 years ago in the Middle East, soap was made using the bases in wood ash. Today, pulp and paper industry, which is a very crucial industry to Canadians, uses huge quantities of sodium hydroxide, which is a base. This base is also used to make soaps, detergents, dyes, and many more stuff. Now let's talk about some everyday life uses of acids. One of them is actually our stomach. Our stomach actually contains hydrochloric acid. This acid digests food in order to prepare it to travel to the intestines. A mixture of sulfuric acid and water as the electrolyte are contained in car batteries. Grapes contain tartaric acid, and as the name suggests, citrus fruits contain citric acid. Also, did you know that by reacting acids with metal, you can make hydrogen? Next, let's talk about the risks. While acids and bases have many beneficial uses, they can be very harmful at times, actually. One must make sure to take the necessary measures to avoid making any mistakes, to avoid any risk possible. Acids and bases are corrosive poisons. They tend to react locally on the human body's tissue cells. Reactive chemicals are almost always either very acidic or very basic. Lungs and eyes are one of our most sensitive organs to corrosive poisons. The cornea, which is located in our eye, could be severely damaged because of acid or base burns. Sinuses, lungs, and also the lining of our nose can get irritated and become waterlogged when cells are dehydrated. The respiratory tract can also be affected by air pollutants such as sulfur oxides, nitrogen oxides, chlorine, and ammonia, because they're all corrosive and will have corrosive effects on our respiratory tract. Even our throat irritation is caused by soluble gases such as ammonia and sulfur oxides, because they get absorbed to the wet and moist surfaces of the upper airways. Nitrogen oxides and chlorine, which are less soluble gases, affect lungs by causing pulmonary edema, pneumonia, and emphysema. Not sure if I pronounced that right. But we just can't mix all chemicals together. Some chemicals just shouldn't be mixed. In fact, these chemicals shouldn't even be stored near each other. This is in fact in order to avoid any risks or explosions or any bad things that could happen. Be sure to keep the incompatible chemicals away from each other. And here I'm going to give you some examples of mixtures that you should avoid making. Acids with cyanide salts or cyanide solution, acids with sulfide salts or sulfide solutions, acids with bleach, ammonia with bleach, oxidizing acids with combustible materials, solid oxidizers with anything. They may actually result in fire. Hydrides with water. They also form flammable hydrogen gas. Phosphides with water. They form highly toxic phosphine gas. Silver salts with ammonia. They may generate an explosively unstable solid. Alkali metals with water. They form flammable hydrogen gas. Oxidizing agents with reducing agents may cause fire or even explosion. Unsaturated compounds in the presence of an acid or a base may polymerize violently. hydrogen peroxide, acetone mixtures, when heated in the presence of an acid, may cause explosions. There are many more I'm not going to go through, but as you can see, not all chemicals are safe, and even storing them near each other can be very hazardous. Let's move on to the last topic, which is dilution, which is another method of preventing accidents when dealing with hazardous mixtures of acid and base. First, I should mention the importance and everyday use of dilution. Weaker solutions can be made when concentrated solutions are mixed with solvent. People actually do this every day with consumer products such as fruit juice. On the other hand, some concentration solutions are used as stock solutions. Dilutions have also caused accidents. Lately, accidents have occurred in healthcare workplaces when dilutions were not done properly. So the inaccurate dilutions led to horrible results such as injury or even death in some cases. In fact, many healthcare facilities have stopped practicing diluting stock solutions because it is too difficult for them to follow the instructions, which is sad. So what exactly is the purpose of diluting? By diluting an acid, you make a strong concentration of the acid weaker and weaker by adding certain amounts of water to it, basically H2O. This lessens the concentration of that acid compared to the total solution. Let's go over an example now. Let's say there's a 12 concentration of hydrochloric acid. How many milliliters of water are required to make 650.0 milliliters of a 3.0 concentration of hydrochloric acid? In order to find how many milliliters of water are required, we use the formula we were all taught by our awesome teacher, Ms. Botticelli, which is C1V1 equals C2V2. So what do these values stand for? C1 is the concentration of the starting solution, V1 is the volume of the starting solution needed to make the new solution, C2 is the final concentration of the new solution, and finally V2 is the final volume of the new solution. So now let's solve the problem. Let's write out the formula, which is C1V1 equals C2V2. The starting concentration is 12.0. The volume of the starting solution is unknown, so you put an X, or just V1. The final concentration is 3.0, and the final volume of the new solution is 650.0 milliliters. By doing the math, you get V1, which is the volume of the starting solution needed to make the new solution. Here, our answer would be 162.5 of 12.0 concentration of hydrochloric acid. Thanks for listening to me talking about neutralization, acids and bases, and the hazardous mixtures of acid-base solutions. I hope it wasn't as boring as the other videos.